Hey guys! Welcome back to my channel. In this video, we're going to be talking about quadratic functions. Quadratics are a really big part of Algebra 1, so we're going to spend the next few videos on quadratics, with this video being focused on key features and transformations of quadratics along with some quick facts. Let's get started. So we're going to start off with a few quick facts. Firstly, what is a quadratic? So a quadratic is a nonlinear function with a U-shaped graph that is called a parabola. So there's a few different forms of equations that a quadratic comes in. So the very first one, of course, is our parent function. Any and all quadratic equations are derived from this parent function, which is y is equal to x squared. Our next type is the most commonly used form, which is our standard form. So y is equal to ax squared plus bx plus c. So when you guys are doing algebra, standard form is what you guys are going to see quadratics in the most. We also have what is called vertex form, which is y is equal to a times x minus h squared plus k. So in these instances, our h and our k is the vertex of the parabola. So now that we know a few of the different types of forms that a quadratic can appear in, let's look at a quadratic on a graph. So to the right, I have two brief sketches of what a possible quadratic could look like. The first one is our parent function. So all quadratic functions or equations come from this parent function after it's been transformed. So below this, I'm going to list out a few key features of the parent function. So as you can see, it's symmetrical across the y-axis, it opens upwards, and its vertex is at the origin. And we can also tell that the domain is all real numbers. The range is not all real numbers. In this case, it's y is greater than 0. Y is greater than or equal to 0. So now that we have this, I'm going to go ahead and talk about a little bit about the graph to our right, which is a transformed function. So I'm going to use this to illustrate some of the key features of quadratics and what transformations can look like. So the first thing that you probably notice here is that instead of opening upwards, our graph is opening downwards. So this is transformed with a negative a value. So you remember standard form, and we have our a right here. So if our a is negative, that means that our graph would be opening downwards. And so that negative a value is the same thing as a reflection across the x-axis. And because of this reflection, it opens downwards. So another thing is our axis of symmetry. So the axis of symmetry is basically the middle of the function. It's where the entire function is symmetric to. So if we look over to the left at this one, the axis of symmetry would be the x-axis, because at that point, everything to the left is symmetrical to the right. For this one, our axis of symmetry would be somewhere around here. So this would be our axis of symmetry, because at this line, everything is symmetric from the left and the right. And so from the axis of symmetry stems our vertex, which is the point where the axis of symmetry and the function meet. So that would be this point right here is our vertex. So the vertex, in the case of a function opening downwards, is the highest point that that function will ever reach. And so if the function opens upwards, it would be the lowest point that the function would ever reach. So in that case, it would be here at the origin. So that is the vertex of our function. And so looking at the vertex form equation, the h value would be the x value of the vertex, and the k is the y value of the vertex. So if you ever want to find the vertex from an equation in standard form, you can always use negative b over 2a to find the x value of the vertex. So for the x value, you can always use negative b over 2a for the vertex and then plug that back into the equation to get the y value of the vertex. The axis of symmetry is also always in the form of an equation, and it is going to be x is equal to negative b over 2a, or the x value of your vertex. So looking at this, you can see that our domain of the transformed function is also all real numbers. So usually in quadratics, it is always all real numbers for the domain. The range, on the other hand, is y is less than or equal to, and then you're going to plug in the y value of the vertex. So the vertex looks to be at about 1, 3. So it looks to be at about 1, 3. And so I'm going to say that the range is y is less than or equal to 3. So the last thing we're going to talk about is your maximum or your minimum value. So this is based on whether your graph opens up or if it opens down. So if your graph opens up, then you're going to have a minimum value. If your graph opens down, like our transformed one does, you're going to have a maximum value. And so we have a max value here. And the maximum value is just equal to the y value of the vertex, which is going to be 3. My next video is going to be practice with transformations with equations of quadratic functions and their graphs. So that's it for today, guys. I hope everything was clear and easy to understand. If you like my videos, please like and subscribe. Also, be sure to drop your comments in the comment section below. Thank you so much for watching. See you next time. Bye!